Hello and welcome to today's launch webinar for IRENA's Global Atlas Bioenergy Simulator. Thank you so much for joining us today. My name is Hui Chen and I'm Junior Professional Associate with IRENA. It is my great pleasure to welcome you to today's webinar. Before we start the program, I would like to go over some technical information. For today's webinar, we have two options for listening in. You may connect by computer by selecting mic and speakers, or by phone by selecting the telephone options in the right-hand panel. If you shall face any technical difficulties during the webinar, please contact the GoToWebinar help desk at the number provided on your screen. Throughout the webinar, we will be asking feedback to know your opinion and improve our future programs. After the webinar, you will see the questions popping up on your screen, and you will simply select your choice. We would also like to encourage everyone to raise your questions during the session. We will be collecting these questions and answering them at the end of the webinar. If you would like to watch this webinar again or share with your friends, we will have a full recording available on the IRENA YouTube channel. We will send you the link to the recording after the webinar. Today's webinar will first provide a short overview of the newly launched Global Atlas Bioenergy Simulator. Then we will present the contribution and partnership with Masdar Institute. You will also hear about the methodology behind the Bioenergy Simulator and the validation process. Then we will show a demonstration. We will conclude the question and answer session, and the entire webinar will be completed within an hour. For those that are not familiar with IRENA, we are the intergovernmental agency mandated by countries around the world to promote the widespread and sustainable use of all forms of renewable energy. IRENA currently has 150 member countries, 30 states in the process of becoming members. In January 2013, IRENA launched the Global Atlas for Renewable Energy. This program was the outcome of the Clean Energy Ministerial process, and it aimed at facilitating open access to the renewable resource data, analysis, and methods in order to accelerate the initiation and development of a broad range of renewable energy projects. The initiative provides freely available online platform that uses a map interface to provide global data on solar, wind, bioenergy, geothermal, and ocean energy resources. Currently, 67 countries and more than 50 institutes and partners are contributing to the initiative, and the interface provides access to 2,000 datasets that can help with renewable energy planning. Our first speaker is Dr. Nicholas Fischok, Senior Program Officer for Knowledge with IRENA, who will offer an overview of Bioenergy Simulator.
Thank you, Hui, and thank you everybody for connecting today. This is a very important moment for the whole team because this is the outcome of a 3 years project, and this is amongst the most complex projects we had so far with this Global Atlas. The simulator itself is more complex than the Global Atlas infrastructure that we had before, and we are very proud of the outcome. So we are very happy to bring that to you today. The first thing we need is to understand where the concept is coming from. And on this screen, what you can see is an illustration from our latest publication at IRENA, the perspective for the energy transition that was presented last month at the Berlin Energy Transition Dialogue. And in this report, it reiterates that to meet the climate goals that are in the Paris Agreement and to keep global temperature below 2 degrees, the emission intensity in the global economy should drop by 85% in only 35 years. And it implies that a lot has to happen on energy efficiency, but this wouldn't be sufficient. and the decarbonization of the energy sector requires urgent action at global scale. So in our scenario at IRENA, we have the Remap 2030 scenario, and in this scenario, we consider that the energy demand by 2050 could be about the same as in 2015, thanks to efforts in energy efficiency. However, this is the way that we produce energy that would change a lot, with the share of renewable energy in the total final energy consumption reaching 60% in 2050. And for this to happen, it means that the growth rate of renewable energy will considerably increase compared to what it is today, including for bioenergy, which is the topic of this webinar today. Half of the total final renewable energy use in 2015 was coming from traditional uses of bioenergy. And in our scenarios, the use of traditional bioenergy drops to almost zero so that in 2030 and in 2050, it would renewable energy would come almost entirely from modern renewable energy sources, but not anymore from traditional uses of bioenergy. And we can look now at what it implies for the bioenergy sector as a whole. The share of renewable energy in total final energy consumption will increase from 18% today to 36% in 2030 and to 60% in 2050. In 2030, the consumption of renewable power would represent 1/3 of the total final renewable energy use, with the remaining 2/3 of renewable energy being used in heating and cooling and in transport. And with these scenarios, it means that the bioenergy feedstock supply would increase by 70% between today and 2030. It's a remarkable increase that we should foresee. By 2030, bioenergy could represent half of the total global renewable energy use, and in this half of that is in heating for buildings and industry, and the remainder is split between transport and power generation. The transport today has the lowest renewable energy share of all sectors, and the share of liquid biofuel and biomethane is going to grow tremendously in the coming decades. And if we summarize that, it means that we are looking for affordable, reliable and sustainable bioenergy supply, and this is a priority to make the entire global energy transition a success. But there are major barriers, and these barriers are the complexity of the sector, the sustainability of the bioenergy sourcing, and also the conflict that can arise with food supply. On the front of sustainability, the Global Bioenergy Partnership published a series of indicators that help to frame the major challenges. At IRENA, we decided to complement this effort by addressing complexity. We thought that we could pull the best and the most complete data sets available worldwide, have them in a single simulator that bridges what the experts know with what the governments expect to have. And this gave birth to this online simulator. And I want to thank and acknowledge all those that supported this project over the last 3 years. So we want to address complexity, but where does this complexity lie? The main problem is that the bioenergy potential is not the flow of a river or it's not a breeze. It doesn't exist. As long as no one plants a seed, grows a crop and harvests, the potential is not realized. The bioenergy potential is only the promise of a land. How this land will be used or not used depends on the soil condition, but it also depends on the end use of the product itself. Therefore, if you want to speak about bioenergy in terms of planning, what you need to do, you need to identify the end use and work backwards to match the sources. We found out that it is possible to create estimates of bioenergy potentials if we were able to take into account as many combinations as possible. And the end result is a very user-friendly platform that is supported by very powerful data sets that cover a wide range of combinations. So 4 bioenergy sources with a number of sub-sources, 25 conversion processes for 3 energy uses. We are not pretending that this simulator is perfect. This is the reason why we are opening it for crowdsourced validation. And what we hope to do is to educate, potentially help to identify priorities, but we can't claim that this simulator provides any sort of bankable information. What we want to do is that we wanted to develop the best simulator that is technically possible at the moment so that we have a solid basis to build on in the future. And I hope that you will be able to help us to improve from this baseline that we're introducing to you today. Thank you for your attention.
Thank you, Nicholas. Our next speakers are Professor Hosni Jadira, Director for the RICREMA Center of the Masdar Institute, who will present the partnership between IRENA and Masdar, and Luis Calisto, developer for the Bioenergy Simulator from the Masdar Institute, who will present development work for this tool.
Hi, well, thank you for inviting us to take part of this webinar. My name is Hosni Jadira. I am the Director of Renewable Energy Mapping and Assessment here at Masdar Institute. We are based in Abu Dhabi in the United Arab Emirates. So I'll be presenting briefly a brief overview of our activities at Masdar Institute at our research center, and later on Luis Calisto is a developer, one of the developers of this bioenergy simulator. We'll give you more details, technical details about the tool. So our research center, we started our partnership with IRENA more than 5 years ago. So we first as a data provider, because we are mandated by UAE government to develop and deliver UAE solar and wind atlas as part of our contribution to the Global Atlas initiative. And also as a co-developer of the Global Atlas platform with many partners in NREL in the US, DLR in Germany, and me, Paritech in France. Can you move next slide? Yeah, this is a quick summary of the expertise we have here at our research center. We are about 12 full-time researchers covering different expertise, mainly in solar technology. So we have three different groups. We have the solar resource assessment team, working mainly at the adaptation of solar assessment with special focus on desert and hot climates. And we are extending our work to the whole Arabian Peninsula. We are working closely in Saudi Arabia, in Qatar, in producing high quality and more accurate solar resource maps. And also we have a team on the technology, solar technology, that are working on improving simulation of performance and different weather conditions. We are also active in meteorology and energy in terms of improving forecasting solar resources with more focus in the desert climate. And you know that here in the region, a lot of projects in the pipeline in UAE and also recently announced in Saudi Arabia. And also we have the computing team that contributed directly to this project in terms of satellite data processing, JS development, and scientific programming. Next. Those are some of the tools developed by our center. So we are developing mainly JS interfaces to host many solar and wind products. The one that's shown here are the solar atlas of the UAE. So it's an interactive tool that you can go online. It's publicly available. You can do your query of the data, yearly data, monthly, and you can see the accurate information about a specific location, about the solar resource potential in one location. And we did the same for the wind to improve the wind assessments. This is showing one of the simulator that we developed recently, and we released the PV and CSP simulator, and we are in the process of integrating those tools in our Atlas platform, and later on maybe extended to the Global Atlas for specific conditions. And this is also the schematic presentation of the Solar Technology Performance Atlas that we are presently developing, that include now different technology, mainly in the PV and CSP, that any user can enter the portal and then select any location. You can simulate performance for a specific location under different solar technology and a different weather condition. And this will help like end user and developer to assess their performance. The atmospheric science team, especially here in the region, so we are more interested in the soiling and dust effect on the performance. So we are running real-time forecasting model for dust deposition, and we are linking this, the output of this model to our to our performance simulation, because we have the sunny condition here, but also we have very dusty environments. And now Luis Calisto will give you an overview, more technical overview about the technology he used in developing this bioenergy simulator.
Hello, my name is Luis Calisto. I was the main developer of this tool. Basically, the selected technology here to develop this tool was based on web standards, and we used web technology to create this tool. Also, we were using very powerful open source tools and very reliable ones to implement this tool. Next, please. Next slide, please. Yeah. So basically, this slide presents the overall picture of the tool. In fact, the user interface is just the tip of the iceberg. In the background, we have several web services which are built in, according to the methodology, and these web services are modular. So the tool can increase complexity, and we can create new modules inside this tool and increase its complexity. Next one, please. Basically, when a user selects an area and when he clicks next, this area, it gets sent back to the server and will intersect in the server with the spatial data sets, which is a very complex database. So we will intersect with the Gazette data sets, and with this intersection, we will know the biomass supply for the selected area. Also, we will have a warning system which is based on protected areas, water scarcity, population density, power lines, etc., which the user will get the information from the database, knowing if there is any protected areas to the population density, if there is any power lines within the selected area. When the user interacts with the interface, this interface will send on-the-fly connections to this database and to this server. And then the interface will adapt with the end user selected values, but this will provide a very simple interface when, in fact, there is a very complex system running in the background. Next, please. The methodology, which in next Arturo will explain, is implemented in the server in the form of web services. So when the user clicks next and before he retrieves the final results, all the data already defined in the process gets sent to the server, and these web services will compute the data in the background. Please notice that these web services are created according to the methodology. Then, when the web services compute the data, they will return back to the client, to the end user, the results. And then these results can be exported and analyzed by the end user. Thank you so much.
Thank you, Hosni and Luis. Our next speaker is Arturo Giovannuti, and he will introduce the methodology behind this bioenergy simulator.
Thank you, Yui, for your introduction. The methodology of the bioenergy simulator is basically built on the bioenergy supply chain, starting from the geographic area for biomass production, and then on the selection of type of biomass, the conversion technologies, and the associated energy and use of interest. According to the selected bioenergy chain of interest, the bioenergy simulator automatically links data and information stored in the database to provide first useful information and possible concerns. For instance, the warning systems embedded in the bioenergy simulator can inform the user if the selected area falls in a protected area, what is the population density in the surrounding areas, or how far is the electricity transmission grid, as well as whether the area faces water stress. Then in the geospatial data warning systems, you can see there is also a data set from the World Bank that provides average on the electricity consumption per capita and other information. Well, this is used in the result to identify possible application on the bioenergy production from the simulation. You will see that during the demonstration. Regarding the biomass productivity, so far the bioenergy simulator is linked to geospatial data only for the potential yield of crops and agricultural residues, while for tree plantation and livestock waste, the potential biomass yields are basically from average global data. The bioenergy simulator combines this geospatial data and specific technical parameters such as the biophysical characteristics, the biomass energy content, the conversion efficiencies of specific technologies in order to calculate actually the potential bioenergy production. Next slide, please. Next slide, please. Okay. Okay, here you can see some of these sources of data used for the biomass productivity. It is important to highlight that biomass yield for crop and agricultural residues are based on data available in the portal of Global Agroecological Zones developed by FAO and the International Institute for Applied System Analysis. While the biomass yield from livestock are provided by IPCC, and wood biomass yield from productive plantation are from FAO and the Forestry Compendium developed by the Center of Agriculture and Biosciences International. Next, please. Then, as a result of an extensive global literature review, the bioenergy simulator also incorporates other biomass technical parameters and conversion factors, such as the energy content of each biomass, the oil content of the main oil seeds, the biofuel potential yield, and energy conversion efficiency of the main technologies. Next. Okay, this slide shows an example of potential bioenergy chain from sunflower oil seeds to electricity produced by a generator. According to the technical parameter bioenergy supply chain, the bioenergy simulator uses associated formulas in order to calculate the potential energy output, that in this case is electricity. Next. Okay, before starting the demonstration, it is important also to highlight the main limitation of this model. In particular, as already mentioned, so far only biomass yield from crop and agricultural residues are based on geospatial data. And then the tool currently does not allow to select a mix of different type of biomass feedstock, but only a single biomass for each simulation. That could be also a limitation, in particular for some bioenergy supply chain, in particular for biogas production and others. Then the energy losses in the distribution network and due to the other operation in the plant are not considered, and it is assumed that the annual operation of the bioenergy plant is 365 days per year. The bioenergy simulator does not provide information on the socioeconomic and environmental impacts of the selected bioenergy value chain and at any scale of the investment. So field surveys and in-depth further assessments should be conducted in order to identify the most appropriate technologies for bioenergy production and for the sustainability. Okay, that's all from my side, and I give the floor to Livia.
Thank you, Arturo. Our next speaker is Livia Spesani, Project Manager for Bioenergy and bio-based products from Valbiom, and she will explain us the validation process.
Hello everyone. So about the validation, from 2016 we started thinking about how to validate the huge amount of data that we collected to build the simulator. As Mr. Gianvenuti just mentioned, data were many, such as figures about methane yield, the calorific value, etc., but also equations and default parameters to transform any surface into an energy output, and that for dozens of feedstocks and also multiple technologies. Moreover, we had to choose values that are average, figures that are measured in a lab, because default values must fit for the entire world. So we were quite confident regarding the accuracy of these values because they are reference values. But we also feared that it would not be in line with figures in real cases at plant scale. Another concern was to find a validation methodology that would be well balanced between time effectiveness and limited dissemination of the tool at an early stage. Next, please. So we made the choice to contact companies and ask them to use the tool to compare results with their real values and provide users with feedback. A short list of companies was selected among a list of hundreds of companies that we know have a bioenergy unit. So continent by continent, for each main technology and for each type of feedstock, we selected those companies that have several plants and or various power capacity, so that we have a large panel of cases. Finally, in order to allow any company to provide a feedback, we added a form in the simulator. Next, please. So with this form, we count on a crowdsourcing validation to keep increasing the simulator. This form is easy and quick to fill in, as you can see on the slide. Our objective is to gather enough data to characterize statistically the error and bias of the simulator, and we would do this by plotting the results against the actual value provided by the users. In the end, this would allow us to provide information on the performance of the tool, because our goal is to be transparent, of course. Next, please. So to conclude on this validation part, what we need today is to get as much feedback as we can. As I mentioned, this would allow IRENA to improve the tool and being transparent on its performance. I also remind you that when you will use the tool for prospection, which is its first goal, you can run it modifying the default values for a result more representative of local constraints. And so that's it for validation. Thank you.
Thank you, Livia. Our next speaker is Dr. Jacinto Estima, Program Officer from IRENA, and he will show us a demonstration for the tool.
Thank you, Hui. So now I'm going to demonstrate how the simulator can be used. For this demonstration, we will be using a real example of assessing the feasibility of producing electricity from sunflower in Zambia In this case, the investor was interested in lowering costs of producing electricity from diesel, as the farm is in a remote area of the country and the cost of diesel was high due to its transportation from the capital city. Previous slide. This is the landing page, and it asks for the first interaction by the user. So in this screen, we should use the we should select the biomass feedstock. We will select crops, and after selecting crops, we land in the map where we should define the area to simulate. In this map, we can also activate information on protected areas and the grid network to avoid being intersecting on a protected area, or to search for locations that are close to the grid network if the intention is to connect to the grid. Can we move to the next slide? Okay. So then the next step is about defining the process, which includes the source, the end use, and the conversion technology. I should draw your attention to the alert system that was mentioned before in this presentation, and that is in the top right corner. We can see that there are no protected areas intersecting the area that we have selected, and we can see also the value, the maximum value for the population density within the selected area. So in terms of defining the process, as a source, we will select sunflower with an intermediate input yield, which means we are assuming an improved management where the farming system is partially market oriented. There is an explanation on this yield if you click on this information button close to the average crop yield. For the end use, can we move to the next slide? For the end use, we select electricity and, as a conversion technology, biodiesel engine. After the definition of the process, a schema is displayed below, showing how the source gets converted into the output. And a short text explaining the conversion technology on the right side is also shown. Then we get into the last step, which are the results. In this interface, the user can see a summary of the defined process as well as the results themselves, where in this particular case, a gross electricity production of approximately 3,200 megawatt hour per year has been simulated. We have also, as Arturo already mentioned, we have also integrated a database from the World Bank that can give us an idea of a possible application of the energy output. I would like to draw your attention, as already done before as well in this presentation, for the careful interpretation of the results. So the user should keep in mind that the objective of this simulation is to understand the potential bioenergy production for a given area, biomass, and associated technologies. The results include the gross energy production at the plant gate. Energy losses are not considered, and the simulator does not assess the socioeconomic feasibility and the environmental impacts. Next slide. And then we come again to this feedback form, which is extremely important for us to provide quality indicators of the tool. You can launch this feedback form by clicking in the feedback button that is below on the left side. And as Livia already said, it's easy to fill in, and it would be an added value for sure for this tool. And that's all from my side. Thank you very much.
Thank you, Jacinto. Now is the Q&A session, and I think we have been receiving quite a few questions, and I think let's pick up a few questions. So the first question is, is it planned to design NUTS related area selection tools for example, for NUTS2 or NATS2 levels? And there's another one question from Alexei, and he's asking, can you select all forms of bioenergy and see them on the map, crops, agriculture, architecture, the selection in the first view of the simulator? Nicholas?
Hello, Alexei. Thank you for your question. So we had this discussion amongst the team if we should display the GAZ data set on top of the map, and we decided not to do that. The reason is that we assume the simulator would be used on relatively short, small areas, and when you display the GAZ data set on top of it, basically what you see are colors, but it's not very meaningful. So it would have been an additional work to add a legend and explanation to be able to put these colors on top, and for the user it was not very clear. So instead of doing that, what we did is that we kept the area selection relatively neat. We put only the grid and protected area, and then the GAZ dataset is queried in the background, and we get values, average value for the area that is selected. But if you display the GAZ on top of it, you don't get much more information on top of the map. However, the GAZ itself is available in the global atlas, so it is possible to see, if you want to see the map, it's possible to see them in the atlas. It's just that in the tool, it was not adding value to the user. It was more creating more complexity and potentially confusion.
Okay, next question is from Gustavo, and he's asking, do you provide database for the Central America?
Thank you, Gustavo, for your question. Yes, indeed, the database, we are using a global database. This is a reason why some country analysis could be more detailed than what is provided by this tool. For example, the World Bank or the FAO have done very detailed country-based analysis. In this simulator, what you will find are potentially coarser results, but we took this decision to use only global data sets. So the FAO GAZ, the World Bank data, the population density, all these maps that we are using are the highest quality that we can find at the highest level of detail, and these are global data sets. We have a question for Arturo from Dora, and she is asking if manure is included in the model as a feedstock or if it's only about plant feedstock. Arturo, can you respond to your question?
Yes, within the livestock module, there is a list of animals, and these animals, I mean, for each animal you can find the manure, and that is actually the type of biomass considered in the simulator.
We have another question that is from Anna, and she's asking, we're promising, and thank you, IRENA, does the tool also include heat generation as end use, including possible connection to district heating? If not, is that possible to expand the tool to include it?
Okay, Arturo, do you want to take this question?
Sorry, I didn't hear you. Can you come again, Yui, please?
Yes. She's asking, does the tool also include heat generation as end use, including possible connection to district heating?
District heating.
District heating.
Well, I think, as also Lewis mentioned, the structure of the tools allows to build on that, and including additional modules and then I guess that the answer is yes.
Okay, we got another question that is from Lindo, and he's asking how often the data are updated to be consistent with the reality on the ground. Maybe this question is for Jacinto.
Yeah, I can take that question. Thank you, Lindo, for your question. So as we are depending on external sources, we also depend on the frequency of updates from these external sources. And so it's really out of our control, but in any case, as Nicola mentioned already, we try to monitor the quality, also looking at the latest available data sets and updates as well.
Okay, we got another question that is from the Gianluca, and he's asking, this is a comment rather than a question. The new Gazette version 4 has been recently produced. Major updates including the new IPCC AR5 model data with the 4 RCPS, which may allow the simulator to provide results also in future modeled scenarios. The portal for data dissemination is under development and should be released in the next month by FAO. Yeah, I think it's maybe this is for Nicholas to make a comment on this one.
Yes. So thank you, Gianluca. So first, we are very grateful and impressed by the work of the FAO on this Gazette dataset. This is absolutely incredible what they are doing. Our tool is coming on top of that, and the quality of what they are providing, free, available to everybody, is absolutely outstanding. We are very glad that there is a new version coming up, and as soon as it's available, we will do our best effort to make it available through this tool as quickly as possible. So there is a partnership ongoing between IRENA and FAO. We have joint programs and we exchange on a regular basis. So this update would be probably part of the next discussion. Thank you for your comment. So there is a question from Dimitrios, and this is a very good critical question. This is a hard question too. He's asking if there is any possibility to assess if there is a food energy competition in the region. So this is one of our concerns with this simulator. It means we are putting a lot of disclaimer, as you saw. We are very careful on this release and also in the tool, because this tool has, he's doing his best to provide evidence of the bioenergy potential, but it can't cover at the moment all the sustainability aspect, including the food nexus. So what we do is that we continue working with experts, and if we find any possibility to provide indication on that, we would certainly add that in the tool. This is the main concern for us. What happens on the growth of bioenergy? What is the impact on the food supply in a region? And this is something we know that is a major limitation of this tool. That's why we are so careful with the release today. We don't want to be over enthusiastic. There are these kind of issues that need to be dealt locally, and this is why Arturo insisted on having local studies being done, local assessments being done. This is very important. There is a question from Andres. This is to Arturo, I think. This is about the bioenergy, the Gazette database, and he's asking if there is any information about the humidity. And he is saying this is because the value would change a lot depending on the humidity. So how did we take into account humidity into the model?
Well, regarding the moisture content of the biomass, by default is set to 0, but there is an informative boxes that invite the user to actually include a value on that, because of course it's always more than 0%. So what is actually is a default values that should be used carefully because the moisture content, when possible, should be added by the user.
Thank you, Arturo. And we got another question that is from the functionalities, and he's asking, is the value based on an average of the world or of an area, takes the yield of crops, for example? I think this question could go to Luis.
So Luis, how are we calculating the averages when we have an area selected? How do we do the average, and how do we put these values into the model?
So basically, by the way, thank you for the question. Basically, the system takes all the values that are inside the area, and it computes a normal average of that. I think this answers the question.
Thank you. I think yes. We have another question from Oliat on the use of the simulator for East Africa. So I suppose you are from East Africa. That's a fair question. The simulator is working in any location in the world. So that's one of the advantages. You can go there. By default, the tool will locate where you are, and it will show you your region, where you are. Then you can zoom in. We would like this tool to be used on small surfaces. It doesn't really make sense to use it on big surfaces. And then you will be able to run a scenario simulation on zones that could be developed, or that where there is an interest in future projects, for example, in any region on the world, including East Africa. For example, you could have a country. They are thinking of planning for bioenergy because they want to change their energy supply. They want to grow biomass, and they identify already some zones, but they don't really know how much it can generate. Is it worth doing it? What kind of technology? Then it's possible to make simulation to compare what can be grown. This will come from the GZ. It will give an idea of what is possible to do on this soil, and then it's possible to simulate the energy output, the net energy output on this type of zone, and then combine and be able to make comparisons on different options to see what would be the most viable on a theoretical basis. And then once you have a range of scenarios of possibilities, then you need anyways to go on the ground, being able to see if that can happen in reality. But at least you can there are so many possibilities in bioenergy. This is if you add up all the possibilities, you have thousands of combinations you can have. At least you can narrow a little bit on what are the few options that you want to target, and be able to have a dialogue with local authorities, with farmers, with municipalities that is based on a smaller choice, on a reduced portfolio of technology or solutions. There is a question from Lizzie. She's asking, what is the link between this tool, the bioenergy tool, and the IRENA Global Atlas? So this is a very good question. So the Global Atlas itself is an initiative, and under this initiative there are a range of activities that we do. One activity is the sharing geospatial information, which is the map itself, the geospatial tool that we have. And then what we have are simulators or different tools that are coming under this infrastructure we are creating. So there are simulators on solar. There are a few of them on different regions of the world. There is a simulator now on bioenergy. This is the simulator we are presenting today. And very soon we will come with a wind simulator that will be able to calculate the cost of electricity from a wind turbine. Again, it's a global simulator. So this initiative is making available data sets from governments and from partners. It's all developing tools and simulator when it needs to be done. And then we do other things. We do capacity building in countries with training on how to use geospatial information to take decisions. And we also do, recently we do site assessments, which are more financial analysis of sites for solar and wind energy. Again, to help countries to take the best decision. This is part of our mandate to help countries to move forward on changing their energy mix.
Thank you so much, everyone. And I would like to thank everyone to participate in the webinar today. If we could not answer all of your questions in this session, please email us at potentials@irena.org. I would also encourage you to connect with us on social media for the latest Global Atlas news. Please pay attention to our upcoming new functionalities such as the Global Atlas 3.0, Global Solar Atlas with SMAP program, and the Wind Energy Costing Tool LCOE Simulator. Thank you again for all your participation, and this is to conclude today's webinar.